Yes, hello friends, welcome to BISP Solutions and myself Ashwin and I work as a just a second. Yeah. Hello friends, welcome to BISP Solutions. Myself Ashwin and BISP Solutions is a tech company provide technological solutions across the world. Now see, this is our another video on DNN. Now here what we are going to do now in our next few sessions, we will be working on transaction data. I will show you how the machine learning, deep learning, they work on transaction data and how they help businesses to take future decisions, right? So far we have learned how they work from the back end, how they work from inside. Technically we have seen all the aspect of DNN, CNN, RNN. I recommend you to watch my previous videos. So far we have seen all these things, but that is not sufficient. We need to understand how these machine learning and how these deep learning they help businesses or even the shopkeeper or the mid-level businesses, how they help these type of businesses to grow further, right? So that is most important, right? So now in this video I am going to show you how this DNN will help a business to grow faster and to analyze the customers behavior. For example, let's take an example. When there were no computer, there were no concept of machine learning and deep learning. What the shopkeepers do, shopkeepers or small businessmen, we say, what they used to do, they just uh, sell the items to the customers, right, without having any track that which customer is purchasing what item and which item they should keep in their stock the in maximum quantity. So there was nothing like tracking. But after this the CRM came, then what happened, the businesses, they used to take the mobile number and after that mobile number they used to send the offers to the customers, right? They run the campaigns also. Then what happened, today also, suppose if there is a branded shoe company and I used to buy those shoes only, so whenever the new stock comes, immediately I got a message, SMS, because no, after all, every 2 to 3 months I buy one set of shoes from that particular brand, or we can say that particular shop. So here DNN will help you to identify that which customer is your lifetime customer and what item is going to be your USP, or we can say which item is sold most of the time and which item is beneficial to, if you keep that item in high maximum quantity. So that is called customer lifetime value. Now here I am showing you customer lifetime value. Definition is a total monetary value of transactions or purchase made by a customer with your business over his entire lifetime. Just now I gave you one example of branded shoes, right? Now suppose I wear a branded shoe company, like let's take company ABC. We are not taking original company name. Let's take any company ABC. Now in this whole city, suppose 100 more IT professionals are there, those who wear the same, those who use the same branded company, that is ABC. Now in that case, we are the customers for that particular branded company, and the customer lifetime value is the monetary value of transaction purchase made by a customer, right? So whatever we purchase, so the company takes keeps a track, right? Every time we buy the shoes, so in that case they take our mobile number and then they send us a soft copy of the bill. That's just an excuse, but they wanted to take your mobile number. So on the basis of the mobile number, they uh, extract all your information from different sources, right? So that's the reason they keep your mobile number, and after that it is easy to run a campaign. It is easy to send you the messages of whatever the newly arrivals or new items they have introduced in their showroom, right? So That's the reason. And here they have to predict the exactly what is the customer lifetime value, which item is the which item is keeping the customer coming back again and again into your showroom. So that is called, so they predict these type of things. Now see here, there is a formula, customer lifetime value. There is a specific formula used here, like CLV, average sales multiplied by purchase frequency. Whatever the average sale is there, and what is the average frequency, and the churn. Now churn, there is a specific term here, churn. And then profit margin. Profit margin, we all are familiar about it. Average sales, we know what is average sales, right? For example, there are two types of shoes, and one brand shoe, they make the profit of 1 lakh, and the other make the profit of like 100 rupees, $100 only. So the average is 50-50, right? Same thing here. Now churn is what? Now see here, where average sales equal to total sales divided by total number of orders, that's we know. And purchase frequency, total number of orders divided by total unique customers, so that's the frequency. Retention rate means again and again the customer is coming. Total number of order greater than 1 divided by total unique customers. Then the churn means 1 minus retention rate, and the profit margin based on business context. So these are the terms which are used to calculate the customer lifetime value. After this, you will see here how to predict customer lifetime value, right? How to predict customer lifetime value. Now see here, let me make here some, that's a typo mistake. Okay, how to predict like customer lifetime value. Now see here, customer data is received through showroom to the head office, right? Then customer features, then preference, their whatever their preferences are, then the product data, product features and their preferences. Then you can see here purchase propensity. So with the help of this is the complete internal backend process, that we don't need to go inside that, but yeah, we need to understand the how the process takes place, right? Now I am showing you one practical example here. See here, I have already prepared this. First of all, I will create one more IPython file, interactive Python notebook. So here is interactive Python notebook. First of all, what I do, I have already the data, I have already a transaction data of the customer, of not the customer, the sales transaction data, right? We will be working on sales transaction data. Let me show you that also. If I just a second, okay, I will show you it later on, just give me 2 seconds. First we will, what we will do first, I will directly pull that CSV data here only, right? So first of all, what we need to perform the operations on any data or any type of data, we need some libraries. Again the same repeated libraries are there. Let's have a look on it. Pandas SPD, Panda is a very well known library which is used for data massaging, data cleansing, data filtration, everything. NumPy is for numerical data type, right? Torch is a library that we are working on, and then that is the neural network, right? Then optimization, then the data set, data loader, and the standard scaler, label encoder. All these things are, we are familiar with this because we have seen so many times, we have already discussed about it. PLT means for plotting the data, and here right now it is working. So just wait for a few seconds. Now see, we will, first of all, we need to read the CSV file with the help of pandas, right? So first of all, load your data set, right? So let's see, I will show you this also. Now here is, just a segment. Here we are having the Excel sheet here, right? Customer segmentation underscore bootcamp, right? So I will just rename this first. Now see here, we have loaded the data set, and now I am going to show this data set to you. Now see, invoice number. Now invoice number is, as I already explained to you, that this is a transaction data. So definitely this is the invoice number. Then the stock code. Stock code means the whatever the item which is purchased. So that is the stock code. Then the description. Look at this: white metal lantern and cream cupid heart coat hanger, everything. Quantity, how much quantity is sold. Invoice date means on which date the item was sold. Unit price is this, customer ID is this, and country is this. Now here we are having the complete sales data, right? Now what we will do, first of all we will massage the data, cleanse the data and massage the data. So how it is done, see here. Now drop NA customer ID, df.drop NA customer ID. Why we have removed this? Because we don't need customer ID, right? No, we have not dropped the customer ID. Actually we have removed the empty cells, right? Whichever the empty cells are there, right? So we have removed all the empty cells, and only the useful data is there, right? After that we will do, if I go here, look at this, and then I will, let's wait for 2 seconds. Here, look at this. What we have done, df as type int. Look at this, customer ID as type int. Previously it was float, but we have to make it as int. Look at this, this is float, so we have to make it as int because there is nothing like float in customer ID. Either 1, 2, 3 is the customer ID, 2.0 is never a customer ID. So that is why we have made it into int. Invoice data, this is called cleansing and massaging the data. Every time you will receive the data that is not necessarily useful or the meaningful, so we have to cleanse and massage the data with the help of these some simple techniques. Now look at this customer ID. If I say someone, my customer ID is 17.222, that's not a meaningful number, right? So what happened here, we have done it as int and invoice date. Now invoice date, only we need invoice date only, right? So what we have done, PD to date time, we have converted into to date time, okay, into a proper format. After that what we have done, look at this. Now here what we have done, in this invoice there are so many cancelled invoice also. When you have a look on this, just a second, let me, customer segmentation, it will not open. If I show you here, there is too much data, so that is why it's taking time. You can see here the 33%. Now look at this, this is the invoice number, and here you will see somewhere, look at this, C means cancelled invoice number. Now after examining the data, it's a duty of the data scientist, it's the duty of the data analyst that he should remove all the unnecessary and unwanted data, then only the analysis will be done, right? So that is why here it is written df equal to, this is a complete formula where df invoice number as type string, where it is a string which starts with C, it should be removed, so that column is removed. So now previously, look at this, previously it was 440,000, 4,06,829 rows, now it is 3,97,924 rows. So all the cancelled sales orders, cancelled invoices, they are now removed. Now create total price. Now see here, we received the data, right? So whosoever has given us the data, he never know that what we are going to do with this data, so that is why he has just given the data only. Now total price, okay, no problem, starting with property by 2, okay, look at this, here total price is that we are having, okay. Now total price, we have calculated the quantity multiplied by price. After that, what we are going to do here, now here if I again customer DF, now group by, now see here we have done group by. Suppose myself Ashwini, if I purchase a particular branded shoe, today I purchase, tomorrow 5 days later again I purchase the shoe, branded shoe, worth $1,000, right? So now what will happen, we have to just to do the analysis, we have to just group by customer ID and we have to add all the total sums, right? That is what we have done here, okay. After that, here encode the country, since this type of data is not, we have to encode the country DF, right? So let me again customer DF, look at this, country name is also encoded, right? So because this data works completely on numerical data, right? So that is why we need the numerical data only. Now rename and define. Now see here what happens here, rename and define means customer DF rename, see invoice, if I go here, invoice number, it should be changed to number of purchases, quantity should be changed of total quantity. Actually this exercise, it is up to you for keeping the things clear. This is just like renaming the headers, right? This is just like renaming the headers. So if whatever they have, the headers they have given you or the client has given you, if you are not comfortable with those headers, so you can, for example, let's take an example, in America or in metropolitan cities, in the school they call it as enrollment number, but in some village areas in the school they call it as roll number only, right? So enrollment number and the roll number both are almost the same, there is nothing difference in that, but for easy understanding, for the ease of working, we can rename them, right? Invoice number means number of purchases, then quantity means total quantity, and here you can say unit price is average unit price. So this is what we have converted the data into our friendly term, right? Or we can say technically used term. Now again the same process that we have been doing for the last so many sessions, X and Y. In this X we will remove customer ID and CLV, and then here in the Y we will put CLV, that is the dependent data, and in X we put all the independent data. Now look at this, everything is converted into digits. Now you will see here the scaling the data. We are now going to scale the data. Scale the data means scale x, scalar y, and x equal to scalar x fit transform. That means what we are doing here, we are just fitting the data to transform, right? So in this way, what we are going to do, that is, we have extracted the data and then we have put it into the x and y, then we will scale the data. Scaling the data means just fit, we are transforming the data to fit the data into that particular train test variable. Okay, after that you will see here train test split, the main subject. Train test split, very interesting. Now you will see here train test split means x train, x test, y train, y test equal to train test split x y. We have provided test size, that is 0.2, and random state is 42. That means the data should not shuffle. Now what happens here? Here we have fit the data into train and test. Right now we are having x train, x test, y train, y test. Okay, now what we are going to do here, let me show you. Now see dataset class, CLV dataset. So here we have created only function right now. We have not inserted anything. We have just created a function. What we have done, self x, self y, PyTorch tensor. This is a standard formula, so there is nothing like we need to go inside it. We are just sending the data here. Look at this. If I go again here, yes, now you can see here now train dataset, test dataset, train loader, rest loader, right? So here what we have done, train dataset. So CLV dataset, x train, y train, CLV dataset, train loader equal to, after that data loader, train dataset, and dataset, test dataset. So we have just passed the things here. Look at this. CLV dataset is here. CLV dataset. Okay. So now we are just passing the data here into the formula. We are not just doing anything. Now see here. Again we are going to create a DNN model. Now here is the DNN model that we are working on. So here you can see CLV model we have created. Now first of all, if the data is sequential, then it will apply a linear function, then it will apply a ReLU function, then the linear, then ReLU again, then linear again. That means we are sending the data into train data into linear, then ReLU, then the fastest data, right? After that you can see here forward. So I'm just going to hit the enter. Now see here, model equal to CLV model here, and now we have just entered the data. We have passed the data, input dimension x, shape 1, that is 1 for one column, right? Then the criteria NN, MSE loss, mean square error loss, and the optimizer equal to optimum.atom, model.parameter. Now what we have done, Now what we have done here, CLV model input data, we have passed the data, MSE loss and optimizer, everything we have just passed the data. Then let's wait for few seconds. Here we have to first define the epochs. Now our work begins here. Now here you can see epochs. Now this epochs, it is running. Now epochs is just like a repetition, we can say. So in the training process, everything is repeated again and again to make a perfect decision, right? I have given you in my previous example, like I have gone to my friend and I noticed that a particular calendar is hanged on the wall, but next time I visited it was not there. Again next time I visited it was there. That means then I come to a conclusion that on this specific day he hangs the calendar. So that is called learning through repetition, right? So let's wait for 2 more seconds. Look at this. Now here the epochs is run. Now what we are going to do here, now the next part is plotting part. Now look at this plotting part. We are going to plot the data. Now look at this, training loss, and here is epochs. The epochs runs, the loss decreased here. That is the complete process, that we, whenever we run the epochs, the complete the whatever the loss is, that loss goes on decreasing, right? So this is how epochs, if you run 300 epochs or 400 epochs, the loss becomes even more lesser, right? Now next is, you will see here, model. Now we are going to evaluate the model. Now how we are going to evaluate the model is with the help of this function. Now I am going to run this function. So once after ending this, we will have one more recap. If it is not clear to you, I will explain you once again. Now again plotting the data. Here what we have done, look at this. So this is how the straight line coming, and these are the blue color is the original and red color is the predicted line, right? So first of all, let's have a quick recap. I know it's a little complex to understand. Let's have a quick recap. I am giving you the scenario first, and based on that scenario we will work on this. First of all, let's have a scenario that there are so many businesses are there today. Now they have the data of the customers and they are selling so many things, but how do they know that which item or which customer is our lifetime customer, right? How do they know? For example, from a suppose how do I take an example? Yeah, suppose a person who is living in a city and he is a student, like he is a student. Now once in a year or once in a month he go to a big restaurant, and daily he is taking the tiffin from a tiffin center. Now lifetime customer of which institution or which business, for which business he is a lifetime customer, or for the next 3-4 years? See, for tiffin center he is a long term customer, and for restaurant you are not a long term customer for them, because you may come next time or you may not come. Similarly, on the highway hotels, they are not their long term customers, right? So long-term customer, the concept of long-term customer means the customer that comes frequently to you in your shop and he purchase some items which are required every month. And which are those items? That items should be kept in plenty of amount in the stock. That is the responsibility of the shop owner or the business owner. So this is how we predict the lifetime customer value, and based on this only the shopkeeper or the shop owner, they run the campaign. Okay, so this is the scenario, and based on this, previously there were no such techniques to predict or to get a rough idea that which item should be kept in plenty of amount so that our sale will increase. Nothing. Okay, so this is the scenario. Now based on this scenario, we are using some techniques. The first technique is DNN, and here you can see, but it always works on numerical value, right? So now you can see here we have imported some important libraries, then we have imported the Excel sheet, then we know that many times the customer ID, now the customer ID might be float here. No, this is not assumption. Whatever the Excel sheet they provide us, now this scripting is written based on that Excel sheet which is provided by the client, right? So first of all, we have seen here the customer ID is float, it's not required, you have to convert it into int, right? After that, convert the types. See here, customer ID is converted into here, and invoice date is to date time. So this is how it is converted. After that, remove cancelled transactions. So we have to remove all the transactions or all the invoices which are marked with C in the beginning, or that starts with C in the beginning. So we have to remove all those invoice numbers also. After that, we have seen here we have got the total pricing also. Right, we have seen the pricing also. Now total price we received. Now the final task is to rename the headers, because we are not habitual with these type of headers which are given by the client. We are habitual with our own keywords, right? So what we have done here, we have just change the name, right? We have changed the header name. After that, customer TF country. Now our main target is to convert first country into the number, numerical value. Okay, after this, what we have done, rename here, what we have done, reset index. Okay, yeah, we have done the resetting index. After that, we have changed the name here, rename columns, right? Then after that, what we have done, we have separated the data. Now from here it is easy to understand. Here we have separated the data into x and y. X means independent variables and y means dependent data, right? Then here I have shown you x and y. After that, scaling the data. Scaling the data means fit to transform into x and y variable. Then immediately xtrain y test, y xtrain x test, y train y test we have to create. Then we have to create a dataset class, right? CLV dataset, and here we have to apply, this is a fixed formula here. Then you will see train dataset and train dataset, test dataset, train loader and test loader. So what we have done, we have just sent the data into this model, this, right? After that, DNN model is used, it comes into picture. After that, you will see here here DNN model is already done. Now we are passing the data into data loader and CSV model. Look at this from here. So what it does, it converts the data. It first of all, the data should be into the linear format, then it will execute the ReLU function, then again linear, then again ReLU function. Like this way the data is received into its correct form, right? Correct format. Now model equal to CSV model CMME loss, and then the optimizer loss. So here is optimizer and optim atom. We have used the optimizer. Then start our epochs. Now epochs means we are training the data. Epochs means we are training the data. This is a repetition, and here again the same formula we have applied. There is nothing new in this, right? Here you will see epochs loss. After that, after calculating so many things, what we have done here, plt.plot, and now we have plotted the data. Now in this plot data, you can see the loss is very much low, right? After this, you will see here model evaluation. We will evaluate our model, and after evaluation of our model, we will again plot the data, and in this way we get the prediction line. Prediction lines is nothing, normally it shows that if you are willing to take this decision, then go ahead. There are so many possibilities of getting success in this decision. That's it. We have to show it using this what we say, this PLT feature, but normally it's a feature that it is just like we are asking our managers to take the decision, and it will be beneficial, right? So same thing is here also. So now guys, I recommend you to watch this video again and again, and then let me know what thing is not clear to you, right? Because in our upcoming sessions we will be working on the transaction data, right, of any company. So practice this and read this presentation and read this PPT again twice, and after that, if anything is not running, then you can put the comment in the comment box. I will be happy to help you. So guys, today is all about this customer lifetime value, and in our next upcoming sessions we will see some different topics also. We will discuss on different topics, and those who are new to this channel, those who watch this channel, those who are watching this channel for the first time, please like and subscribe the channel. So today we are concluding this session here only. Tomorrow we will see some other topic. Okay.